Here we have ticket number 12795, and it's a faulty Nintendo Switch that needs a port swap if I can get it into frame. It does in fact have a torn trace, so we need to do trace repair, and it was sent in by a viewer. Which, on that note, if you do need your device sent in for repair, please feel free to use the link down below in the description for our mail-in service. The viewer did also send all of the parts for the Nintendo Switch, so I'm going to put that back together afterwards as long as I can make sure that it works. But I should then at least be able to test it fully. Let's take it under the scope and just quickly inspect to see if we've got any shorts or what the damage is like. All right, here we are under the scope. The reason it looks like this, the customer has obviously attempted their own repair, but has unfortunately come across some personal circumstances which then allows them not to pursue with the repair any further. Flux-wise, I don't know what flux they've used. It's around P13 as well. I don't know if that's been replaced. It doesn't look like it. I'm just making sure that we've got all our filters and caps on the back in the correct positions, which it does look like they are. I'm going to clean up a lot of this flux just by heating up the board with a hot air gun and making sure that our area to work in is nice and tidy. And we'll get rid of the solder that we have in these ground holes, because I don't know what solder the customer's used, or the flux for that matter. This cap does look like it's holding on for dear life, so we'll secure that back down properly. And the trace that we have an issue with is this one, which I am just going to double check because I don't know if it's ground or not. I've got a feeling that it is, you know. Do you know what? I think it is ground, so I don't even think that really we need to replace this trace. All the traces on the bottom row seem to be present as well. But yeah, I think this is just ground. If I put the meter into continuity mode and just use the shield that we have up here and touch on this pad. Oh no, it's not ground. Okay, the one next to it is, right? Yeah, this one's ground. And this one is ground, even though it's connected to this. I think I know that this one is ground, as is this one here. And actually this one here. So the ones on the end are ground. Maybe this one isn't ground then. Okay, so we will need to replace that. First off, clearing out the flux on the back of the board. So we'll just quickly blasting the heat over just to make sure. Just give it a nice clean. You know the drill, isopropyl alcohol and a cotton swab. There we go. Does it need to be cleaned? It's not. I mean, it's not a necessity. If it was around the port and stuff, yeah, but there we go. All right, that's a lot better than what it was clean-wise from the flux. Now we just try and get this solder out. What I'm going to do first is just tin everything with leaded and then come in and remove it all. Let that solder soak in. Hopefully we've got no more other ripped pads when we go over. No, we don't. Perfect. Grab our wick. These ones usually clear out just using wick. The other ones I'm going to have to use hot air for. But again, we don't know what solder's been used before. Okay, another quick clean. Just to see where we're at. Back over to our hot air gun. Now to clear the ground holes out. And another clean. There we go. Okay, looking all right. Make sure the back of the port is still all good, which it is. Now we need to do our little trace repair. Rotate the board this way. Actually, just fill up all of the holes and stuff again with some more leaded solder. Because, as always, we like to use our drop method with Nintendo Switches. And I'm actually now just cleaning up this flux to use new flux for that trace repair. Zoom in a bit more as well. There we go. We've already tinned our pad, so we're just going to add a tiny bit of flux just there. Actually need to hold the wire a bit closer with the tweezers. There we go, perfect. We'll give it a cut just about there. Isopropyl alcohol and our toothbrush just stroking alongside in the same direction as the trace, and that's our trace repaired. I'm going to have to cut it a little bit shorter because I don't want it touching anything below. So it's in a good position right now. It's solid, so it's not going anywhere, which is also good. But I'm actually going to have to trim it. So again, we'll just take our knife and let's go for there. There we are. Okay. Dry off the remaining alcohol with some hot air. And again, just make sure that it's not touching this below. There we go. Nice. I'm not too sure. It might be the same line as this one, but we don't want to take that risk ultimately. So rather just have it not connecting to anything. Take a little bit of conformal coating and just put it up here, as well as, I don't want to do that much of a big blob, to be honest. So I'm just going to, I think I've actually just got a bigger blob. Let's try that again. Just to make sure that we're not going to short out between these. Yeah, there we go. Perfect. And then also just spread this out so it's nice and thin. There we go. Now we cure it with some UV. That's now hardened and is all ready to go. We can put our new port on. This bridge in here is fine, again, because this is ground. And as you can see, the previous repair attempt has taken away some of the ground leg that was here. So, you know, it's going to be tough to avoid this. Once we put heat through the board, though, this is going to sink through. So it'll just make it a strong connection. For everything else, we look ready. I'm just going to tin the port. Do you know what? I've only just seen. How have I missed that? There's another rip trace here. I don't know if that was at the start of the video or whether I've literally only just seen it. Either way, that was bad for me. Good job I've spotted it now, but we have another rip trace here which needs sorting, so I'll do that quickly. Again, a little bit of flux. There we go. Just chop that off. Heat the board quickly just so we can get rid of the flux easy. IPA and downwards. Just want to make sure that's not going to touch that. Again, tiny bit of conformal coating just around here. Now we can put the port on after I've tinned it. Port has been tinned and ready to go. I'm just going to make sure that we don't have any shorts around M92T36. M92 is fine. And just BQ as well to confirm. All okay. Just going to tin that little wire just to make sure we're all good. There we go. Now ready to go ahead and just drop the port on. We're going to add some flux. The solder is just starting to wet now. You see it slightly changing colour. And any second it's going to drop through. Just waiting for that bottom left one. Right, it should be good now. Now place the port on. Give it a bit of a shimmy. Make sure it's pushed down through all the way, which currently it's not. There we go. There's the drop. That's why it's important to hold the heat on. Continuing to hold the heat on. I just want to make sure as well that solder on the bottom right sticks around the leg. Here we go. I'm just going to push down on the port now. And come off the heat. Keep holding, keep holding. There we go. Now I can let go. Now we take the board out the holder. We just make sure that everything is attached how it should be. So, for this part, we're just going to apply some flux just here. Again, a little bit of solder on the end of the iron, just a tiny bit. And we're just going to go over. That might be a bit too much. Smaller bit than that. There we go. And just make sure that these pins are all connected. I think we have a small bridge that we need to sort out in a sec. I think that bridge is now gone. There we go. I think we're okay. At this point, we don't have to use IPA because the board is still very much warm. Now we come in with isopropyl alcohol. And just make sure we're all clean. Check the pins from this end. Yeah, they look all solid. And that trace that we had on the second one in looks good as well. Let's just test it. Yeah, connected. Good, 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 good. All right. And now we'll do the back of the port. Isopropyl alcohol and another clean. And there we go. That looks all good. Still a little bit fluxy in some areas. And again, we like to leave it clean. Nice. And then the only other thing that we have to do is really quickly on the back, even after we've just given it a clean, is just get rid of these big solder blobs. Just putting a little bit more heat back into the board because I've had to step away for 2 seconds. And now we just put a tiny bit of flux here, here, and here.
That other one is okay, so we shouldn't need to worry about it. Drop a solder on the iron. Just make sure it all flows through nicely. And leaves us with that nice finished product. There we go, that's better. Finish off with a quick clean. What looks to be, you see those like burn marks that we have either side of the port, just like on the actual PCB itself, was from the prior work done. I don't know if maybe too much heat was put into the board. There we go, that looks so much better. Doing the repairs on your own board is no easy feat, and I'll always give credit to anyone who attempts it. But with enough practice, you'll be able to do it. Oh, we had that little cap earlier as well, didn't we? A little bit of flux. There we go. Now we're going to give it a quick test on the power lead on the USB-C connector, just to make sure I get my normal reading, and then I'm going to put it all back together, hopefully, as long as it works. And as always, I'm praying for a nice, happy customer. Let's give it a test. All right, let's go. So this way round to start with. Do we get anything? What do we get? We're looking for something. It has recognition. 100 milliamps, drops down to 0, 15 volts, perfect. Do we have the same on the other side? If we do, we're on to a winner. Recognition, yep. Something on the ammeter, 100 milliamps, drop down to 0, 15 volts. So it shows both sides charging, which is exactly what we wanted. I now need to put this back together and then test it in a docking station to make sure that we actually get a display on the TV. But so far, so good. Right, so story time. It charges both ways. I put it into the chassis that the customer provided. However, I don't get a display. I can see that it's booting up. It takes a 500 milliamp draw and then boots up to around about 700 to 800 milliamps, which means that it's going into fast charging. The ammeter turns off and then turns on, so I know I'm getting something. And like I said, the backlight is showing. I tried 2 other chassis, both that I know work, and again I get no display, but I get a backlight, so I know that the backlight on the board is fine. I also know from inspecting over and over that the LCD ribbon connector is also okay. I can't see any bent pins in this LCD ribbon connector at all. Everything looks fine. The soldering itself is factory, so I know that it's definitely not been replaced. And when I was measuring some components, I was looking around the fan connector area to see, I stumbled across this chip here. Now, I've personally never changed this chip, or even potentially looked at it. I'm going to go ahead and assume, though, it's responsible for some sort of display image on the switch itself. And as you can see, it's not all square. There seems to be a chunk of it missing in this top left-hand corner here. Let's see if I can get you a better image. And if we zoom in like that, you can see that the top of the chip is gone. So ultimately, it got me thinking. We've got what looks to be these little resistors up here. And when I measure going into the chip, I'm getting a 2.4 voltage drop in diode mode on the first one, 1.6 on the second one, on the third one 0.7, on this cap here 0.7, on this resistor here 2.5. Now I'm going to introduce you to a donor board with the same IC just there. Measuring the first resistor, what do we get? 0.7 voltage drop instead of the 2 point something that was on the other one. That's 0.7, that's 0.7, this cap 0.7, and this resistor is actually 1.9. But these two here, I think, on the other one, are measuring way too high. Again, this is 0.7, 0.7. On the customer's board, 2.6, 2.7, and 2.6. So way too high. I think I'm going to need to change this chip. I am wondering if I can just do a straight swap. Depends on the size of the balls underneath. But I do need to be super careful because it is next to that connector. Apply a little bit of flux. Also have to be careful of this bit of plastic here as well. In a really awkward position. Just need to get a better grip. There we go. Nice. LCD connector, fine. This plastic up here, fine. I'm just going to tin the pads with leaded solder and see if that does the trick, to be honest. Okay, that's actually come off fairly easily, so I'm just going to put this here. There we go. You see it pop into place? Just give it a tiny bit more heat just to make sure. Should have enough flux. LCD connector still fine. I'm just going to try and give it a little nudge, just a tiny one. Okay, good. Just wanted to make sure. Wait for that to solidify, and then we'll come in with the clean. And I'm just going to check those readings again. I'm also just dabbing with this at the moment rather than wiping left and right because I don't know how fragile this chip is. All right, it could also be that the resistors have gone bust and don't have a great value, but let's check now. Multimeter is in diode mode. Do we have the readings that we need? What do we get here? Yep, 0.6 here. 0.6 here, 0.6 there, 0.6 there, and 1.8 here, which is the same as the other one. What do I get here? 0.4, and here, 0.5. So I think actually we're okay with this chip. I'll put it back in the housing now, give it a test, and hopefully we fix that as well for this customer. Okay, the switch is now in the housing. I'm literally just plugging in the battery now as we speak. Bare minimum is obviously being connected for obvious reasons. We've got screen connector, backlight, and battery. I'll show you guys. I have no idea if this works or not. We get something, that's good. Anything on the screen, come on. Yes, there we go. All right. So we get the charging symbol up here. Does it actually turn on? It's resetting the ammeter. It's good. 800 milliamp draw. There we go. We have a display. Look at that. I haven't put the game card slot reader back in so we don't have touch, but now I can at least put this back together and test it in the docking station. I'm actually going to move the camera as well today and not be lazy about it. But as you can see, it also works on a docking station. I've just tested Joy-Cons with it as well, and it works absolutely fine. That's every aspect of the Nintendo Switch now working. So again, I think it's going to be a really, really happy customer. Thank you so much for sending your Nintendo Switch to us and trusting me to work on your device. If anyone else needs a repair, like I said, link in the description. If you're watching on TikTok, just send us a message and I'll get back to you as soon as I can. Thanks for watching, and I will see you in the next one. Peace.